Now, we will be discussing more on your individual bands, that is the data provided to you will be different bands, and we will have to understand and work on the how well you can use the satellite data. You can see here a natural color composite, as I was telling you, 3, 2, 1, blue, green, red, how we are using applying. False color composite, 4, 3, 2 bands, how it will appear. So, the same area, two different periods, two different enhancements, false color composite and a natural composite, how it will appear. So, in this context also you can see a natural color I am able to understand or identify the individual building here, but here the same area it is appearing in another tone, it is not appearing, they are showing a natural color here. So, kind of a grayish color, isn't it, a bluish gray. So, that is how there will be variation. If I know what is the requirement, I can decide what is to be done. Now, classification techniques, how to enhance the data, how to classify the data, you should understand. So, when I am working with this, I am talking about kind of a say classification. Before that, we have to process the data. So, coming back to the display or the stretch or the combination, stretching of data or data enhancement we call it as. Data as it is provided to you may be band 3, band 4, band 2, depending upon the application I told you, we choose one of the bands or 3 of the bands, and then we try to work on the stretching context. So, this is what is your various bands, and we have the filters. What we try to do is that I try to understand the spectral characteristics of that particular band, and I find that I will not be having the data well enhanced, because as I told you, very reflection of the energy is based on the object. If the object is something like a very unique object like green vegetation throughout, there is no difficulty. If it is not so, I will not be in a position to identify the object directly. Then if I look at the spectral data, I will find the variation will not be much as far as spectral values are concerned, or the digital numbers or the gray levels. It will be between say 44 to 66, but the advantage in image processing is that my data is in 44 to 66, but my facility will be 0 to 255 levels, isn't it. So, in that context what I will do is that I will try to correlate the 0 to 44 and 255 to 66. So, the values between 44 to 66 is stretched between 0 to 255. So, that is what is called as stretching, contrast stretching. Once I stretch the data, naturally what will happen, all the data which is clustered between 44 to 66 is stretched very widely. One of the most important stretches and applications in image processing. When I stretch the data, I will be in a position to understand much better than what was there, because when it is only between 44 and 66, I will not be in a position to understand the object clearly. So, when I stretch the data, obviously the data will appear very bright and natural. So, contrast enhancement is one of the stretching techniques in image processing. Similarly, we also have edge enhancement. What we tend to do in the case of edge enhancement, for example, I am interested in only in the roads in a given area, as far as say something like a urban application. I am not interested in the objects which are surrounding the roads. I want only the roads to be enhanced. That means I will have to enhance the roads in such a way all others are suppressed. See, one is enhancement, other one is suppression. I enhance the roads in such a way I will be in a position to see distinctly the roads. So, this is a very good application for understanding contents or what is present or how well the roads are structured. So, in that context we enhance the roads based on edges of the roads, isn't it. So, any linear object, if it is present, we enhance the data in such a way we raise one, suppress one, or elevate one, suppress one, edge enhancement. So, this is one very good example of various techniques what we use for say enhancement of image, satellite image data. So, the data provided to us is in the form of say digital numbers, and that will not be accurate, I mean in the sense not accurate, in the sense it will not be that very self descriptive. You will not be in a position to identify the object of your requirement. So, in that case we will have to enhance the data in such a way I will be in a position to clearly or easily decipher the data which is present on the Earth's surface. So, image enhancement is one of the important topics in your say satellite data image processing. Now, I have enhanced the data, I have made the data much easier for me to identify. Now, what am I going to do with the data? So, instead of having the data in digital numbers, I am going to enhance and keep it. There is no point, isn't it? I will have to do something with the data, because ultimate aim I told you is to identify the objects on the Earth's surface. Now, let me see how you can work on that. So, I have just seen either I use a natural color composite or a false color composite. I will be now satisfactorily, I will be in a position to supervise the data and classify the data. Classifications are two techniques in basically they are two in nature, two types of classification. One is called as supervised classification, other one is called as your unsupervised classification. As the name indicates, supervise the classification. How are you going to supervise the classification? Various techniques are there. Before going to the supervised classification, the data has to be processed. As I told you earlier, either it will be radiometrically corrected or geometrically corrected. If you are intending to correct it on your own, you can also obtain the data in different bands and start working on the satellite data. Well, looking at the slide, we will know what exactly is radiometric correction and what is the geometric correction. As I was telling you, radiometric earlier itself we have seen that the data will be with respect to the spectral characteristics of the data. Any kind of a changes or variation which will affect the appearance of the data, that is what is your intensity level, which is nothing but called as brightness values. So, to correct those errors, especially those occurring due to atmospheric effect or the sensor errors, which are relatively difficult to be corrected by individuals, but still scientific research can be carried out and then you can correct the data. Well, if you have the data already provided which is radiometrically corrected, or if it is geometrically corrected, you can also do the same thing like rectifying the data, image data, and rubber sheeting the data. To rectify in sense, we will be bringing into a specific spatial position and see that the data is directly used for any kind of further application. So, if you just look at the geometric rectification, you see how the data is provided, and after rectification you find the data is inclined. So, this is the way the earth also will be there, this is the way the path of the satellite also will be. So, initially what we get is this is the data. After geometric correction of making all the removal of the noises, atmospheric effects like scattering and all those things, suppressing rather, then you will be getting an output which will be in this form. The form you can see a slightly inclined, because all of you know earth is a object which is slightly inclined, it is not a vertical object. Similarly, I told you while processing the data you will have to think of enhancing the data such that you will be in a position to understand what is present where. To process the data, you have to know what kind of application you have. Just one simple example I am talking about is edge enhancement. Enhancing the specific object, suppressing the surrounding object. So, let me say something like if I want to enhance a water body, you can see that it is relatively dull in nature. The water body is there and the surrounding objects are also there. I want to enhance or I want to study more on the water body, then I will have to go for say enhancing this particular satellite image with respect to the water body. When I do that, you see how the output. Don't you see how beautiful and how simple it is to see? Now, water body has been enhanced and all others are suppressed, or other way around, all others are enhanced or water body is suppressed. Here a water body is enhanced. This may appear bright, that does not mean that it is correct in understanding. You will be in a position to demarcate the water body much better than when compared to this sun. So, in my context, I want to demarcate the water body accurately. So, in that case, I will be going for edge enhancement, and edge enhancement is a very popular technique. Then we talk about say linear stretching. Stretching the data where we find data is clustered within a particular range. Say for example, 60 to 100 or 40 to 140, but the range what you have is much higher. So, for example, you have 0 to 255 levels, you do not have to restrict yourself to that 40 to 100. You can now stretch the data in such a way you will be in a position to work with that particular data in enhanced manner. So, let me show you how enhancement is being done. In the sense extending the data from lower levels or lower limits to much wider limits. So, this is what is the enhancement. As you see here, before enhancement the value was minimum here, maximum here. What we tend to do is that we try to correlate this minimum value to 0 and the maximum value to 255. It could be any value, just to give a range. So, the range here is from here to here. It has been now stretched from here to here. That means we are using or utilizing the values which are already available. This is the range available 0 to 255. But the actual value which with respect to the particular object with particular satellite, this is the range. That means it is not capable of reflecting beyond this. But we are not going to alter the reflectance characteristics, but we can enhance the data by stretching it to lower limit and to a higher limit. By doing so, we will be in a position to enhance the appearance of the data. So, as I was telling you, ultimate aim of all this enhancement or kind of classification is to understand what is present where. So, in that context, it is always important to enhance the data before working with the data. That is what is we have done in the case of your image enhancement. Just I am giving a detailed example. Minimum value is remapped to 0 and the maximum is remapped to 255. Here it is 60 to 158. So, this is what the value I have. So, what I have done is we will be enhancing it in such a way the 60 is correlated to 0 and 158 is correlated to 255. So, obviously what will happen, the linear stretch will enhance the data and stretch it to the maximum possible limit which is available. Provided you have 0 to 127 levels, then this would have been 0, this would have been 127. As I told you, most of the applications we go for 8 bit, hence we have 0 to 255 levels. Now, you see how the output will appear. So, output appearance is very important here. You see a very dull data. Of course, in the last case we saw edge enhancement, the same similar image rather, you find that this was enhanced. Now, you see what we have done is we have enhanced. So, this is what is the actual value. This all cluster you see, the entire thing is concentrated within a very short range. Whereas, now what we have done is we have brought the values and you see how spread out it is, and we have used the entire range of available spectrum 0 to 255, and that is helping us to enhance the data. And now, in the previous case edge enhancement, we enhanced the water body. Now, we are enhancing the surrounding objects, because water body once it is done, you do not have to bother about that, you will have to work on the other surrounding areas. Similarly, when you are using this linear stretch on multiple images, the previous case we have just done on single image. In the sense one single band, any one band we will do and enhance and then use it. You can also do similar enhancement on multiple bands. So, when I am working on multiple bands, especially when you want to go for a true color or a false color composite, it will become much better and brighter. So, you can see that also in the next slide, where you see literally invisible, you are not able to see any objects, it is a true color 3:1 image. Now, the same true color image I have just enhanced the data. So, this is what actually will be there. See how beautiful it is. Now, I will be in a position to demarcate. You can see how well I can even see the agricultural fields. These are agricultural fields where various things are there. Of course, this is the open land with maybe a little salt affected and things like this is a barren land, and these are the various agricultural lands or vegetation lands wherein which you find it has been enhanced from nowhere. So, this is what is the advantage of say enhancement. Now, as I was telling you earlier, any kind of study or anything what we do is that we are supposed to identify all the objects on the earth surface, whatever which is in your purview, then use that data as input into some other system. So, as we find that over a period of time, remote sensing output has become a very important input into GIS. So, what we try to do is that collect the satellite data, interpret the satellite data if it is smaller scale, or map the various features if it is a larger scale like infrastructure facilities and things like that. Take the output of the remote sensing data as an input into GIS data. So, that is what actually we are trying to do, and this is what I will be explaining you. Output of remote sensing data becomes input into GIS database for further analysis. This is what actually happens. You see here, this is the original data which has been provided. Now, I enhance the data and classify the data. So, we will come to that point of classification. So, original data, classified data. When I classify data, this will again be an image, it cannot be used directly into any other environment. So, what we tend to do is that we can use this as a background in GIS to digitize the data to get the output, or we can also digitize it or classify this directly and then convert it into vector data, and that can be transferred or put into as an input into GIS environment. Now, classification, what exactly, because we are just telling about the satellite data acquisition, satellites, types of satellites, satellite data acquisition, then processing the image data for understanding in a better way and classifying the data. So, unless otherwise I will be in a position to understand what is present where exactly, it will not be possible for me to classify. Hence, we enhance the data before classification. What kind of classification can be done? There are two types of classifications. One is your supervised classification, the other one is your unsupervised classification. As the name indicates, you can understand supervised classification. That means, as a supervisor, you supervise the classification step by step. Same thing when I am using unsupervised classification, it is not going to be easy. That is, you are not going to have any hold on the data. The data will be classified by the system itself. That is the whatever you have algorithm in the software, that will be converting the data or classifying the data. So, that you have to bear in mind. So, when you come to the two types of say classification techniques or strategies, supervised classification. So, we impose our perception on the spectral data, whereas in other case the spectral data imposes constraints on our interpretation. So, you will not have any control or anything over the data. So, in the first case, how we are going to do that, we will see. So, let me see or show you a slide where in which a small area has been considered here. Now, this area contains 3 different types of objects. So, do not worry about what exactly is that, but still if you want to have a look at it, I can tell you. A yellow color indicating deciduous forest, blue color indicating water body, and the green color indicating conifer forest. So, each of them will have or present in the entire area. Now, to classify the data, supervising method step by step, we have to train the system or train the sets, give a training set such that the system will understand what is present where. Though we know from here to here it is all green color, of course, it is a very enhanced one, it appears like that, otherwise it will not be so sharp. So, you will find it a little overlap will be there. So, what we do is that we try to train this particular object according to the area or according to the type of object. Now, here in this context conifer. So, we what trying to do, I am just trying to create a small area or digitize a small area or a polygon and make the system or get the characteristic spectral characteristics of this particular area, and then train the system and tell. For example, if the range of your spectral values of this particular thing is say between 45 and 65, then you say between 45 and 65 whatever is present in a cell or in any of the cell, you consider it as conifer. If it is something like between 20 and 24 or 20 or 26 or 20 or 32, anything between that spectral value you say or the brightness value you say this is water. So, the system will classify according to your training set. So, what it does is it takes into consideration every individual cell. So, just not only by giving the range, we also go for the statistical data. So, the mean, median and all the details also will be corrected, and then we will just decide, we will tell the system from this range to this particular range is a water body, this range to this range is your vegetation. Again, if you are very particular about the vegetation, what kind of vegetation? As I told you, it could be paddy, it could be wheat, it could be millet, whatever is that. So, you decide and tell the system this range, because as I told you in the very beginning, satellites will not know what is what. It will only give you digital numbers based on the reflectance, and we also seen that every object has got its own reflectance characteristics. So, naturally depending upon the type of object, it will reflect that. So, once the reflectance is ready, values are ready, you try to make the system to understand this range is a specific object, and the system will automatically start classifying. It is a simple mathematical algorithm which is there in any kind of a classification software. On classification, you find that how the values are now converted, and then you see here, this is the original image, a multispectral image where in which I have just told the system this is what is your variation. And you see here very interestingly, though I find this blue color on my satellite image, I have given the training set only here. You remember that? I can also show you that the previous one. See here, I have given the training set here, I have given the training set here, I have given the training set. See, because of that, what has happened, you see. So, it has not taken into consideration all the values, how beautifully it is classified, you see. It is because I have given the training set here, it is classified only up to here. That means it is not clear, it does not understand what exactly is this object. And similarly, as I given here, you can see here only this is classified. In the case of course, once this is similar, it is considered. When I take to the entire green color, I have given one sample set here, and the training set has not classified the other areas, and you find that there are as many as this many unknown cells. That means system is not capable or understanding assign this particular cell to which of the classes. It is not able to, it is not in a position to say that this particular cell belongs to that particular class, unless otherwise we refine the say the training set. So, what we do in such a case is that we start refining the training set. So, once we start refining training set, that is by giving more and more training set, you make the system to understand every individual pixel which is present. It may be, as I told you, millions of them. You cannot train millions of them, isn't it? You will have to train only part of it. So, we identify a specific area in a given terrain, and we say this is what is the specific water body. This could be a vegetation, types of vegetation, this could be a land, this could be urban land, this could be a road and things like that. Once you try to give the training set properly, automatically the system will be in a position to classify that, and you will find a land cover map. You can see how the final result has come. This is the water body, and this is what is your conifer or whatever is that vegetation, and this is deciduous forest. So, a land cover map is generated from satellite data which is given as a raw data to you. Now, what kind of classification types are there? So, we say normally parallel piped, maximum likelihood or minimum distance to mean. Of all these three, this maximum likelihood is the most important one, and which is the one which is in vogue. So, when you talk about the parallel piped minimum distance to mean, that does not mean that it is not in use, but it is very useful in sense how it is done. For example, parallel piped approach, what does that do? We try to, as I told you, we just try to give a training set here. So, what it does is, it just takes into consideration as a pipe like, you see this is a pipe like structure, moves this along the entire area and then picks up whatever is present within that. See the beautiful concept part of it. So, it just moves like here and then finds her. See, in this context there is nothing found here. So, it will automatically reject that area. It will come here, it will pick up this area. It is falling, it will try to compare the characteristic of this every cell here and then put them together as a parallel pipe and then ultimately classify the data. A very simple one, but the assumptions are too many, hence the classes may be that may not be that very accurate. So, then you come to the minimum to mean. So, minimum to mean distance. So, we talk about that, I told you statistically also we try to analyze the data, I mean in the sense whatever data we get satellite data, that digital values are we do not use only these range, as I told you 40 to 50 or 30 to 23 or something like that. We also go into consideration or consider the mean value and the median value of the data. So, minimum distance to mean. So, this is the mean of the entire area, what it does, and this is the mean for this one. So, every cell is taken into consideration, it will calculate the distance from here to here, from here to here. So, minimum distance to mean. Obviously, what will happen? This particular cell is supposed to be belong to here, these cells are supposed to be belong to here. So, very simple technology, and then we try to classify based on the minimum distance to mean. So, it will find the mean values of the entire pixel of the training set and then try to compare and then classify the data. The most important thing I told you about is your maximum likelihood classification. Another statistical approach, where we try to use that, we not only consider the mean, median and other details, we also go into consideration of the normal distribution of the data. So, when you try to use the normal distribution, so we also use statistical analysis, not a simple one of mean and mode, we also go for the distribution of the data. So, normal distribution and how well each and every cell is maximum likelihood, to what extent it will be attached to a specific classification group, as we already told water body or agriculture or whatever is that will be content. So, for each pixel it just calculates the probability that the pixel may or may not belong to that particular class. So, it takes into consideration mean and the covariance of the training set, and it finally classifies the data. And the pros and the cons, when I say talk about this one, so it is very much sophisticated and definitely you will get very good results, but requires lot of training and good knowledge about the area. So, that is what we call it as strong training is required to get accurate results. Of course, as a scientist or a engineer where you are trying to use the satellite data, you should know what exactly you are doing. If you understand and if you know what is that object which is present, that is by understanding or looking at the object, then the training set also will be of high quality and the outputs also will be of high quality. So, that is about your supervised classification technique. And then you can also see that you should understand the classification technique is not simple. You can go for n dimensional space. So, wherein which we try to use or say that data can be not only in 2 dimensional, it also will be 3 dimensional and analyze the data properly and get the ultimate output. Yes, when you talk about advancements in some of the techniques which is there, so we say that there are neural networks, contextual classifiers and linear regression. So, neural network, as all of you know, that artificial intelligence, it is dependent not only on the characteristics of the your spectral details, it also takes into consideration the spatial characteristics, namely for example pattern of a specific object. For example, if you have a housing board houses in a given terrain, so what is the characteristic of that? You will find that almost all the houses will be in similar shape and size, isn't it? So, we don't not only take into consideration the spectral values of those houses, we also take into consideration the spatial distribution and the spatial size and shape. So, when I say spatial size and shape, I find that the data or whatever is the shape of that will also be considered along with your say spectral. So, in that context, you cannot just take the statistical details or the spectral values or the brightness values, you will also have to consider the spatial shape. So, shape size, in that way we say artificial intelligence comes into play. So, neural network is one technique by which is just try to create an artificial intelligence into the system and make the system to think like how a human being thinks and then digitize. Because when I am doing a visual interpretation, not digital interpretation rather, when I am doing a visual interpretation, I can easily demarcate the objects directly, because I know as a human being I am much intelligent, I know what is present where, I can demarcate the object, even the overlapping areas also I may ignore. For example, if a water body is stretching into a little into a say forest area, I may give importance to water body, because we know that water body at that instance of taking the image it will be present, but a dry area a little away from the water bodies also may also belong to the water body. So, what we try to do is that we try to give intelligence to the system and then analyze the data and finally go for the classification. Finally, we talk about unsupervised classification. Unsupervised classification is one of the coarsest method of classifying the data. We do not have any control over the type of data. I just have told you, as an individual I am capable of understanding what is what as an object, but when I talk about unsupervised classification, the system does everything. It does not know what is what, it just takes into consideration the values and simply classifies the data. You can see here how the data has been classified just in the case of your supervised classification. In the previous case you find these are all the various data which are all classified, but in now you see these are all become a little more lighter in nature, unknown, white as well as the say your green color. Now, you see how different it is when compared to the previous method. The previous method all these things were classified and the output was appearing better. So, whatever we do it will be very difficult. So, research a supervised classification, this will be the result, and unsupervised classification, this will be the result. So, that is what is the importance like classification technique. But incidentally these are the ways in which these colors two of them are appearing as both conifer. This light yellow and dark yellow is appearing as hardwood, but here everything is shown as hardwood, conifer and water. So, advantages and disadvantages depends on what kind of application you have, and we can also use these techniques very extensively using simple software like ArcGIS, which contains your image processing technique, or ERDAS Imagine is another software which is exclusively meant for image processing software, and you try to obtain that and then get the satellite data, analyze the data and then interpret the data, finally come out with the output. Thank you. That is the end of your topic on image processing of satellite data. Thank you.